Hello. Shall we start now? Actually, we are 5 minutes ahead. Hello. My voice is audible?
Yes, sir.
Okay, Ganesh. Chalo. Shall we start? I think, have you seen my previous recorded video lectures? The chapter 3rd, that C programming, some basics I had taken, how to make the assembly code under C, and then interfacing of various modules. 5 modules are there. That is LCD matrix, ADC, DSA, and stepper motor. Okay, chapter 4 is very small, 2 hours lecture is there, chapter is there. Then after that, I have recorded the video of taking chapter 5, peak microcontroller basic features and the architecture. That some in the last lecture only. And then I started with the chapter 7, peripheral features of the peak microcontroller. Sarvani video बघितलेत का? का बघत ते पण नाही बघितलं? Have you seen it? So after recording lecture, I am putting on the group. Please go through that and complete the what task is given. Have you seen lectures, Meenakshi? ते पण नाही बघितलं?
No, sir.
का madam? Himani, Swami, Aishwarya. कधी बघणार मग लेक्चर? Hello. So please let me clear that we have the POE exam. So though you were having under impression that we have the exam online, so we can clear that. But while POE we are making the camera on, we're taking the orals. So that time you students are not able to speak or give the answers of simple questions. Okay. So what are the videos are recorded? Please go through that. Go through the videos of that. And please try to get it what things are explained in that. If it is at all getting problem, ping me, we'll discuss that point also. Okay, chalo. And things about that write-up completion. So maximum students have yet not submitted the assignment as well as the practical write-ups. So as in when you are getting that completion, getting time, please complete it immediately. So before 25th is deadline for that. Before 25th, if somebody is not submitted, I'm not going to allow for that POE exam. That students required to come in the department, take the permission, then things will be proceeding. So please don't force to go to that level. You are now mature the students in the 3rd year ENTC. So get it done as early as possible. Chalo, let us start. We'll start with our lecture. The screen is visible?
Yes, sir.
Okay. So last lecture I have discussed about the actually I started with the chapter number 7, peripheral features and the programming of that. Okay. So in that, if we talk about the that's why I explained the chapter number 5. What are the features of the peak microcontroller, peripheral interrupt controller? This one of the controller in the section second we are going to see. And most of the part in the chapter number 5 and 6 have been called by the guest lecture sir. Still I am repeating that part in previous lecture. So what is the peak controller and what is the architecture, what are the features, how it differs from the 8051, why it is called as a RISC. Yesterday somebody has put me message. So RISC means what? It is a reduced instruction computers. Okay, specifically we call it as computers, but it is not computers. By default it is a microprocessor or the microcontroller, which drives the system, and that system formed with the computers. Okay, so basically if you talk about the PIC 16F877A, it belongs to the category of the RISC processor. And the basic difference between the RISC and CISC in chapter number 1st we have seen. So means it is a reduced instruction set computers. its meaning is that particularly this IC has only 35 instructions, and with that instruction only we have to go for the it's all programming, toggling the ports, configuring the ports, all these things, all the multiplication ports are there. Little bit complex is there this programming, but easy is there because we have only set of 35 instruction, and basically we have that called as a word register and the file register to use the programming. Not like that we have the R0 to R7 registers in the 8051 and A and B registers. Okay. Rather than that, we have the work on the file registers in the PIC microcontroller. It doesn't have the accumulator, all these things part, A register, B register, but it has the stack pointer PC that is required for all the controllers. And also, it supports for the pipelining execution, means speed of operation going to be enhanced. So, meaning of pipelining is that it is having the three-stage pipelining, means three instructions at a time. If you are giving in the code, one is goes for the fetching purpose. Fetch means what? It goes in the ROM memory and understand what action required to take by the controller. Second, decoded. Second stage will be decoded. Decoded means what? Instruction decoder identifies what task to be taken or action could be taken by the controller. And the last step is called as a execution. So it has the fetch, decode, execution. These steps in one cycle. That is called as a pipelining execution. That comes under the RISC category. If you talk about a PIC, we have the embedded processor. Here we have the three stages go to the 5, 7, 8, 11. When go the ARM 11, ARM series, ARM 7, ARM 9, ARM 10, ARM 11. Okay, so means the number of cycles instruction execution is going to be increases. Simple calculation: 1 million MIPS. Okay, 10 MIPS processors are there. Means 10 million instruction per second can be executed. We talk about the ARM series processors are there. ARM 11, ARM 15, ARM 12 now, or Cortex M3 series are there now there. Okay, म्हणजे एका सेकंदामध्ये millions of instruction can be executed. So that much faster or that much stages of the pipelining implemented in the advanced processors. So we are talking for the PIC controller has the three-stage pipelining. Okay, so little bit if you compare the 8051, it also has the on-chip devices. Just upon bucket let's see how the students, but the things I had discussed also in previously architecture diagram. It has the 5 ports. Okay, then it has the accumulator, work registers, on-chip serial protocols are there, SPI, SCI, I2C. Some additional features are there if you compare the architecture diagram of the 8051 and the PIC. Okay, so without wasting time, in that first, these are the outlines I have shown for the last lecture also. So it has basically 3 timers. Out of the 3 timers, we have seen the first timer. And timer means what? Please go through the previous lecture. I explained that part. And 8051 also I have discussed about this. Okay, now we'll get the timer 1 operation. So basically, when we talk about timer, so I'll revise this part, small part of that. What is meaning of timer, all this thing. So timer is a device which provides the different time delays based on the how we are going to be configuring that. Okay, so timer is a device which provides the different time delays. So basically 3 timers are there: timer 0, timer 1 and timer 3 in the PIC microcontroller. Okay, PIC is what? Peripheral interface controller. आपल्या syllabus आहे 16F77A family. We have in our syllabus. So what is F also? I explained the previous lecture also. Please go through that. F is means the ROM memory of that. It is made with the flash type memory is there. There is sometimes C is there. 16C77A. C means what? The CMOS logic family is used for that. So we have the various TTL, HTL, RTL, and CMOS logic families. Out of that, which family used for implementation? That is configured this F and the C. So normally when we go for the interview questions in the industry, HR interviews, technical, that time specifically they are asking for that. What is the 16? What is F7? A is what? A is it's a version of the controller, and the 16F is it's a series. हे पण मुलांना कळत नाही नॉर्मली 16 काय आहे सर F काय होतं F तर काय द फ्लॅश टाइप ऑफ रॉम मेमरी यूज करतो म्हणून आहे ते Please go through the previous lecture. You'll understand that. So out of that, the timer one is of only 8-bit size. If 8-bit size means what? 2 raised to 8. That count is going to be always FFH. Means 255. Sorry, 256 decimal. The count value can be taken. Also, it has support for the 8-bit count value as well as it is a 8-bit prescalar. Now, what is meaning of prescalar? Simply, I'll explain here. It will multiply with the 1:1, 1:2, 1:4, like that, back to the 8. Means if I design the timer for getting the time delay of 2 seconds with the help of the 2-second time delay, with the help of the prescalar value directly multiplies. So we have the prescalar multiplied by 2 multiplied by 4 with our count value. So I can produce directly 2-second time delay with the help of the prescalar multiplying of maybe 10 seconds or 15 seconds. So meaning of the prescalar is what? Multiply the count value with the multiple of 1:1, 2, 4, 8, like this. Depends upon the size. It is 8-bit size. So maximum count will be multiplied with the 1:8. Okay. Meenakshi, are you getting the things? कारण बऱ्याच दिवसानंतर आपण लेक्चरला परत रिजॉइन झालेलो आहोत.
Yes, sir.
हा. So आता टाइमर 0 चं ऑपरेशन मी सांगितलेलं आहे. We'll talk about timer 1 now. So I'll take the timer 1. So timer 1 is the size of 16-bit. Okay. So it has a 16-bit timer as well as it has the 8-bit prescalar value. Prescalar's meaning काय? First multiply. I explained that also part. I plus plus I and D plus plus I. Okay. Post increment the pre-increment meaning is that. So prescalar indicates first multiply the what is the prescalar value 1, 2, 4, 8 and then go for the count. Okay. Means it is a 16-bit timer means 2 raised to 16 will be किती असतं ते 4 times H means 65,536 in the decimal. Okay. So once we have loaded the count value this in the timer, so timer is a 16-bit. That's why it has the timer 2 resistors. Okay, timer 2 H and the timer 2 L. So lower byte and higher byte. We talk about 8051. We are using the TH and the TL same way. Okay, if the timer 0 is there, I'm using TL 0 TL 0. If it is a timer 1, here 1 not 2, it's a 1. TH1 and TL1. Same process. Frequency घेतो आपण crystal frequency त्यातून T find करतो दिला T on divided by microns T on period T that gives me initial count value. Okay, and that count value काय करतो आपण subtract it from the our maximum count. It is a timer 1 timer 0 16-bit size in the 8051 also. So maximum count we have the 536, but it has the various modes in that. Mode 0, mode 1, mode 2, mode 3. जर आपण बघितलं previous ST तिथे जरा बघून घ्या. त्याप्रमाणे 13-bit timer 0 timer 0 is 8051 मध्ये 13 bits आहे, 8 bits आहे, 16 bits आहे. Timer 2 is 8-bit mode operation. Mode 2, sorry, mode 2 is auto reloaded 8-bit mode. Okay, same way in the peak control also it is a 16-bit timer. That's why the maximum count to be loaded is going to be 2 raised to F is nothing but 4 times FF. We starting with the 65,536. So what is the count I'm generating? That delay value I can upload in the these two registers. Okay, means once the count value is uploaded, आपण काय करतो? I'm setting the timer. कुठला timer आहे? Timer 1. Set B timer 1. Means once timer is set, so what is the value is getting minus that value. From that value, it starts incrementing. And once it reaches to the maximum value of what? This count. The roll off occurs and the interrupt going to be occurs. This is history for the all the timer operation. Count load करायचा त्या count पर जर पर count येतो clock pulses either external internal घेत जाईल. Once the count value is reached to maximum, roll off occurs means interrupt can be generated. Means next action can be taken. To store this value, in case of 8051, we are using the TH and TL. But here the nomenclatures are different. TMR1H, TMR1L. These two registers are used for that. Let's understand that also here. So timer 1 is a 16-bit timer as I mentioned. means the maximum count value can be taken 65,535. So that maximum count will be there. Okay, and to hold this count maximum, I'm using the I means what that controller by default they are having the two resistors, that is timer 1 L resistor, timer 1 H. So one will store the higher count value and one will be lower count value. So we know that 16-bit means what? If I got value like this 3B 4E, so 4B goes in the TMR1 H resistors, and the 4 will be going in the timer 1 lower byte resistors. Okay, and from zero value, so from this value, you start incrementing to the FF. Once roll off occur, this value reaches to this value by comparing, flag will be raised, timer 1 flag. This is the process for that. And these are the features for that, as I mentioned, 16-bit timer ahe. So it's a programmable by using the, means I can provide the time delay, I can use the internal as well as the external clock source. It has a 3-bit pre-scalar value. So can multiply to get the once I design timer for the 1 second. So for 3-4 seconds, I can generate with the help of the multiplying the pre-scalar value. Okay, and once roll off occurs, means once count value overflows, I can generate the flag, interrupt flag. Okay, and timer 1 also act as a capture compare mode. So basically timer 1 can be used for the capture and the compare mode, and timer 2 for the PWM generation. This is again one of the features of the peak controller. It supports for the capture compare mode. And what is that? We'll see in the lecture. Next point will be there that. So which resistors are used in that? T1 con, timer 1 control resistors. And the timer 1, these are the resistors for to load the values. Have we got timer 1 in the peak controller? कसा आहे कसं वर्क होतं?
Yes, sir.
Just time waste करत नाही आता प्रत्येकाला विचारायला. Okay, because we have to finish with the chapter 8 also before the 25th. Chalo. So these are the resistors, T-con resistor for the peak controller. Okay, if we specify that bit number 7, 8, it is not used, keep up future scope. Then bit number 6 and 4, 6, 5, 4. So it is used for that 5, 4, 6, 7 will be and 5, 4 will be there. So the T1 CKPS1, that will indicate the time, T1 for timer 1, clock pulse. Okay, clock prescalar value selection. So based on these 2 bits, what value can be multiplied will be taken. As I mentioned here, 1:1, 1:2, 1:4, 1:8. How they decided? Based on this timer control resistors. Means if this value will be 0, 0 in this bit T-con resistors, like this we are move T-con 0 values will be. If this was 0, 0 means the value can be loaded for the multiplying 1:1 only. Okay, then timer 1 generates 1 second window. By default value 0, 0, it provides the time delay of 1 second. Then when I use this value 0, 1, that will be select the input clock prescalar value 1:2. Means I will, if it design for the 1 second output, I will get for the 2 seconds. So it multiply with the 2. Like this 1, 0, 1:4, 1, 1, 1:8. So to select the prescalar value, these bits can be used. Then so I can either use the internal or external clock oscillator to for this enabling. I'm using this bit number 3. That is called as the timer 1 oscillator enable bit. So it is called as the timer 1 oscillator enable control bit. Means if its value is going to be 1, so internal oscillator is going to be used for that. If its value will be 0, external clock pulses can be used for the providing the time delay. Things will be 2 types. Either can use the internal oscillator or the external. Based on the value 1 and 0, that can be configured. Next, if I'm using the external oscillator, I need to synchronize the clock speed operation of the external and the internal. That's why I have the T1 sync. So based on this bit T1 sync, I can synchronize the external clock input with the help of our internal clock control operation. Means if the 1 will be there, T sync will be 1, as it is active low pin. 1 means what? It will not synchronize. It will be asynchronous more simple way. Okay, if this bit will be 0, that time the external clock pulse will be synchronized with the input clock. That is the meaning of that. And then TMR1 is a timer 1 clock source used, means either can use the external or the internal clock source. And last bit to make the timer on. As I said that here, once count is loaded, I am making the timer on, set timer 1. So in that T-count register, if this bit will be 1, I'm starting the timer. Once timer will start, what is the configure, कुठल्या मोड मध्ये आहे, कुठला स्पेसिलर आहे, हे व्हॅल्यू सगळं टाकून काय करणार आहोत मी, टाइमर स्टार्ट करणार. बस timer started, it start from that value count taker and goes to maximum FF. Once it reaches to 4 times FF value, roll off occur, the flag will be raised. This is a T-con of the timer 1 control register, how it is used. ते सांगितले मी, लास्ट बिट कुठलं तर टायमर 1 क्लॉक सोर्स सिलेक्शन मी एक्सटर्नल यूज करतोय का इंटरनल क्लॉक यूज करतोय. आणि लास्ट बिट होतं बिट 0 टायमर ऑन करण्यासाठी. 1 असेल तर एनेबल होईल टायमर 1, 0 असेल तर स्टॉप होईल. If you are you getting the things, and I'll show the block diagram of this. Same way what we've seen, आपण बघितलं बघा 8051 मध्ये मोड ऑपरेशन, मोड 0 ऑपरेशन, मोड 1 ऑपरेशन, मोड 2 ऑपरेशन्स कसं होतं. जे क्लॉक ऑसिलेटर पल्सेस आहेत का आपण देतो अँड गेट मध्ये, टायमर 1 केला की ते काउंट पल्सेस, क्लॉक पल्सेस जे दिलेले आहेत त्या व्हॅल्यू स्टोअर करतो आपण टायमर 1 लोअर रेजिस्टर मध्ये आणि टायमर 1 मध्ये. अप टू दॅट, फ्रॉम दॅट व्हॅल्यू इट गोज टू द मॅक्सिमम FF. जेव्हा तो FF ला जाईल काय होणार, रोल ऑफ होईल आणि फ्लॅग इंटरप्ट विल बी जनरेटेड. म्हणजे आपल्याला जे ऍक्शन घ्यायचे ते आपण घेऊ शकतो. आणि हे जे प्रिव्हियस आहे बिफोर दिस पार्ट्स काय करतं, एकतर मला एक्सटर्नल क्लॉक पल्सेस करायचे आहेत का इंटरनल करायचे आहे. ओके, जर तुम्ही बघितलं बघा टायमर 1 CS म्हणजे काय सांगते हे, टायमर 1 क्लॉक सोर्स. जर 1 असेल तर इंटरनल यूज करायचं, सॉरी इंटरनल यूज करायचं. 0 असेल तर इंटरनल, 1 असेल तर एक्सटर्नल साठी. If you go to the previous diagram, I will show it here. This bit, timer 1 CS. काय सांगते ते? Timer 1 CS, if it is 1, use the external clock oscillator. If it is 0, use the internal crystal frequency. Okay, म्हणजे I can use the clock pulses to generate either external or internal. Same way, based on these bits, म्हणजे काय, timer 1 CS bit जर 1 असेल तर I'm using the external clock pulses, which is connected to the external crystal oscillator. And if it is 0 bit, timer 1 CS, I'm using the internal clock frequency. Okay, and also I have the T1 oscillator enable control bit. म्हणजे मला ऑसिलेटरला एनेबल करायचं आहे, जर 1 असेल तर एनेबल होईल, 0 असेल तर डिसेबल होईल एक्सटर्नल क्लॉक ऑसिलेटर. त्यासाठी पण एक बिट आहे, बिट नंबर 4 ला आपण बघितलेला आहे त्या कंट्रोल सिस्टम मध्ये. ओके, देन if you talk about the T1 CK PS1, bit number 4, 5, 2 bits are there. It will select the Scalar multiplication. When 1:1, if it is 0, 0 bits, if this bit will be 0, 0, it will multiply with the 1. If it is 0, 1, multiply the 2. 1, 0, 4, 1, 1, 8. So prescalar can be selected to multiply the count value. Means multiple of 1, 2, 4 like that. Okay. If I'm using the external crystal oscillator, I need to synchronize with the interclock. That's why I'm using the sync bit is there. Bit number 3rd bit, I think, in the T-count registers. Means TS1 sync आपण म्हटलंय बघा, ऍक्टिव्ह लो सिग्नल. 0 असेल तर काय होणार आहे, सिंक्रोनाइज करेल ते क्लॉक पल्सेसला. 1 असेल तर करणार नाही, बाय डिफॉल्ट ते हाय सिग्नल गेले. सो आफ्टर ऑल दिस थिंग आय एम एनेबलिंग एक्सटर्नल और इंटरनल क्लॉक ऑसिलेटर. कुठला मल्टिप्लाय यूज करतोय मी, प्रीस्केलर 1 का 2, 4. Once all I said what is the clock pulses coming here, once I start the timer 1, then that clock pulses will be sent here and that stored in the timer 1H and timer 1L registers. And once timer started, from that value it goes the count value to increasing up to the 4 times FF. Once that match occurs, the flag will be set. This is the timer 1 operation. Understood? I think. Hello, you call the timer 1's operation?
Yes, sir.
Okay. Similar way, we have the timer 2 also. Let's go with the timer 2. Working with the mention केले तेच आता जे सांगितले, what I discuss here, same way it will be will operate. If I use the whiteboard here, I can write on that. आहे कुठे whiteboard इथे दिसते का? Or I need to select whiteboard. तुम्हाला माहिती आहे का कसं यूज करायचं व्हाईट बोर्ड वगैरे ते? Clear our drink. Do save erase bottle stamp draw. मी करू शकतो का ड्रॉ इथं मग आता? नाही, असं काय ड्रॉ करून फायदा आहे? That will be lines. Okay, text. आता पेन नाही का लिहायला? Can you use the pen for writing? I think this one. Okay, so I can use this, but it will go to erasing now immediately. Just I'll check on that whiteboard is there or not. This one. I'm not able to use that. Okay, let's no go. Don't trouble. चलो ठीक है. दिसते स्क्रीन दिसते सर्वांना? It's visible. स्क्रीन विजिबल आहे का सर्वांना?
Yes.
Okay. It shows arrow. This is line. It will take text. It's mouse. Okay, ठीक है. Okay, so the second is a timer 2. So as we know that timer 2 size is going to be again 8-bit is there. So timer 0 8-bit, timer 1 16-bit, and timer 2 of 8-bit only. So it's 8-bit means what? 2 raised to 8. So that will be FF. Again it vanishes. So don't worry, leave it. So same like other timer operation, timer 2 also supports for the 8-bit only. So maximum count can be taken is of what? Up to the FF. So by FF, because size is going to be 8-bit, but it has some changes in that. If you compare timer 1, timer 0, it has the prescalar values, but timer 2 has, it is 8-bit size. So 2 raised to 8 means FFH, or 255, 256 count can be taken for the loading the providing the time delay decimal value. But timer 2, it has additionally, I can have the prescalar and post-scalar. Means after providing the time delay of 1 second, if I need 4 seconds, so using the post-scalar, I can use it. So post means and pre means previous also explained. If you talk about pre means plus plus I, and I plus plus is the post. So if you is in the for loop, I'm defining a certain variable for I equal to 0, semi-comma I less than cancel the value 10, and then I plus plus. Meaning is that initially it will assign the value 0. It will check it less than 10 condition, and it will increment this value I plus plus. Then increment. But if I use here plus plus I, meaning is that it will increment the first and then check the condition. It is less than or not. What is the value coming? Getting the things? What is the meaning of pre in the post?
Yes, sir.
Same. Then it is 8-bit means what? It has the timer 2 resistors. That is the loading the count value. So once I use the delay value FF for this 250 side, that value will be loaded in the counter, the timer resistor value. So once loaded by using the Tcon 2 resistors, I can control its operation. Either I'm using the pre-scalar multiplication or the post-scalar multiplication. Okay. And same way, what is the count loaded in this value? Incrementing to the FF value. If I loading in the 4B, so from the 4B, it goes to the FF. Once the count value over, the flag will be raised and the timer, what is the timer 2? Interrupt will be there. That can be raised here. Once raised, I can take the action. So for that also we have the registers for that. Okay, so features 8-bit timer ahe. It can be programmable for the pre as well as the post call scalar. Then interrupt can be occurred once count value will be overflows. Same like a previous timer operation. What are the registers supported in this? Tcon timer controlled register 2, then timer 2 registers to load the value, PIE. So it will be interrupt generation enable for enabling purpose and the interrupt register such as that IR and IE. Okay, so P stands for programmable registers is that. That is meaning. Let's go with its Tcon registers. See, again, it is an 8-bit Tcon register is there. A 7 number bit is not used. So from the bit number 3, this is 0, 1, 2, 3. That is a T out PS0 to the T out PS3. That bits are used for the selection of the post scalar values. So post means, as I mentioned here, so the 4 bits are there. That is called as a, I'll use other color to show it. T out PS, I think it's a 5 or 6 to the T out PS3. Let me check that same is there. PS0 to the PS3. So from bit number 3 to 6. So these 4 bits are there. Now if you observe that 0, 1, 2, 3, 4 bits. So based on the values, these 4 bits 0, 0 to maximum 1, 1, 1, I can select the post scalar factors. So in case of timer 2 operation. And what is that value? We have to see that here. Okay, you can see here. If that bit number T out PS0 post scalar values from this 0, 0, 0, 0 means I am selecting post scalar value multiply 1:1. As 4 bits are there means what is maximum count? 16 bit, 2:4. Okay, and that's why with 001, 001 will be 1:2, 0010 will be 1:3, like this maximum 4 times 1. So that time I can select the post scalar value 1:16. The meaning is that if you go for this, so post scalar value is 1:16. If I generated the timer for the 1 second, once these values were over, and if I selected the these bits for T out PS0 to T out PS3 1, it will multiply this count value with the help of the 16, 1:16. What is the count value will be 1 second. So it will produce the 16-second time after that generation of the 1 second once count is over. Means it first generate the 1 second time window, and after that start the post scaling multiplying with the count value based on the bits used in that. That is meaning of that. This is for the these 4 bits, 3 to 6. Then bit number 2 is for what? Making the timer on. So timer 2 on. So when will be there? Makes timer on. 0 will be timer 2 off. Then T2 clock powers selection, pre-scalar value selection. These last 2 bits are there. T2CK, PS0, T2CK, PS1. So it is 8-bit only. So that's why 2 bits are there. That's why four possible combinations only for the pre-scalar multiplication. So it has both post as well as the pre-scalar multiplication with the counter value. 2 bits are there means what? 1:1, 1:2, 1:4, and 1:16. Okay, if 0 will be there, 1:1 only. 0 1, 1:4 only. And in 1 value or 1 0 value, it will be 1:16. So 1:8 is not there. Huh? Sorry. If the 1 0 or 1 1 will be multiplied the 16 times, means pre multiplication and then produce the time delay. That is meaning of that. Let's go with this block diagram. See here. So we have the timer 2 resistors in which I am loading the count value. Okay. So what is the count value stored? I am comparing with the what is resistor value 2 stored in that. Okay. So once a match occurs, that will be generate the flag. Okay. So what count value I can generate the flag with the same time. What is the count value coming in the after that? So after generation of the time delay, post scaling is starting here. So I can multiply that count value 1:1 or from maximum 1:16. Okay. So what is the delay is coming? With that delay, I'm multiplying with the post scaling factor. And after multiplication, that value will be reached. Then the timer 2 IF flag will be raised. Same way. Otherwise, if these bits will be 0 0, no multiplication will be there. Means simply once count value is over, the flag will be set. This is for the post scalar multiplication. If in the last 2 bits, if I use the pre-scalar value 0 0 1 0 0 1, so what is the clock signal is coming with that multiplication values count value design? It can multiply to that value first and then start comparing in the what is value stored in the PR2 resistors. Okay, that is for the timer 0. Sorry, timer 2. So simple meaning, I design for the clock of 2 seconds. If you multiply with the 1:4, the 8. So that 8 value will be coming in the TR2 resistors. Start comparing with the PR2 value. Okay, means once value will be matching, that time I can occur the interrupt, means overflow occurs. This is a timer 2 operation. Then the working of that timer 2 is mentioned as I discussed here. I can use the timer in the either post or the pre-scalar multiplication. If the both the post and pre-scalar 0 0 values are their bits 4 and 2 bits, that time simply operate a simple timer operation. Okay, next module. So that what timer is there? That timer can be used as other additional feature. Same way I can say timer counter operation just but they act as a timer as well as it is used for the capturing the certain data, or sometimes we can use for the comparing the some data in the timer registers, or it can be used as also PWM generation. And PWM आपण बघितलंय की duty cycle माझी change झाल्याप्रमाणे the PWM module mostly used in the speed control of the DC motors or servo motors. So clock pulses can be produced at 50-60%. जर आपण बघितलं असेल बघा थर्ड किंवा फोर्थ प्रोग्राम असेल आपल्या चॅप्टर 3 मध्ये की जनरेशन ऑफ स्क्वेअर वेव्ह विथ 50% ड्युटी सायकल and the 67 duty cycle. When we talk of 67, T on period is going to be maximum. म्हणजे तो PWM output. Just I'll write here that part and then we'll discuss. So we have the CCP. So first C stands for capture. मुलांना परत हे पण लक्षात राहते बरं का काय फुल फॉर्म आहे ते. सेकंड C is for compare and the P for PWM. So capture ची meaning काय आहे? So when my clock signal is going on, I want to capture certain timing interval. So for example, in the capture register, I have the capture register 1 and I value stored is going to be 8 nanosecond. So when the 8 nanosecond will come, that time the value will be captured and stored in the again these registers. Okay, that is meaning of capturing the data. Comparing means what? At certain value, I want to compare with the what is signal going on, and that time I want to take a certain action. So in the compare register, CM register, I can store the 8-bit value as 8-bit to 16-bit. Okay, depends upon that. The value stored, start comparing with the incoming signal, and when the match occurs, I can take the action. Just I'm explaining the feature of that. Then how it will be there, I'm going to look in that. Then we have the PWM generation. काय सांगितलं PWM चं? Pulse, if you see the PDC or the analog communication, we know the meaning of PWM, pulse width modulation. Pulse width modulation. यात काय होतं? The width of the carrier pulse is going to be changes. If it is a 50%, if I want more than 60%, I can increase it. It will be 60%. I can produce 70% also. This will be 70%. I can produce 80% also. Okay, means I am defining the duty cycle T on period. This is called as a T on. This is a T off. Okay, it's built on. And this is my total T. So I'm defining duty cycle is equal to T on divided by T on plus T off. Okay, means based on the T on, I am controlling the speed of the DC motor. So I can generate the various duty cycles, square waves or other different waveforms, the different duty cycle to control the speed of the DC motor. जर तुम्ही डिस्क्रिप्शन वर बघितला, we have the conveyor belts आणि या conveyor beltला काय करतो आपण, मोटर कनेक्ट केलेली असते. This is my motor and the packets are going on this conveyor belt in this way. बरोबर नाही, मग त्याचं स्पीड मला कंट्रोल करायचं असते. हाऊ टू कंट्रोल द स्पीड? आय कॅन कंट्रोल द हेल्प ऑफ द दिस PWM आउटपुट सिग्नल्स. जर आपल्या हे असेल बघा, सागर थोरातला माहिती आहे, ही इज वर्किंग ऑन दॅट वन ऑफ द PWM मॉडेल फॉर दी सेंड द पल्सेस टू कंट्रोल स्पीड ऑफ द रोबोट. मीनाक्षी, कळालं का PWM चे मीनिंग काय?
Yes, sir.
Still I will draw the diagram here to understand that, because this part will be there in again next semester embedded system. जर मी घेत असेल तर मी तुम्हाला 100% सांगेन तुम्हाला. ओके, काय केलं बघा मी इथं, आय हॅव यूज्ड द वन ड्रायव्हर and this signal I am applying the this duty cycle or PWM signals. I can say PWM1 50% duty cycle. आता काय होईल बघा, ज्या टायमाला इथं बेसला मी 50%चा T1 पिरियड दिले, काय होईल, T1 ट्रान्झिस्टर ऑन होईल. किती वेळेपर्यंत? up to the T1. Once this transistor is on, what is the motor I am connecting? This is my motor M, DC motor, VCC दिलेला आहे. काय होईल, the current starts flowing from this loop. Once current flows means what? DC motor runs. Correct? Is it correct? Simple meaning. ट्रान्झिस्टरच्या बेसला इथे काय असतं, एक डायोड असतंय. इफ यू ऑब्झर्व VBE, जर तुमचं इकडे चांगलं असेल तर हे कळेल. When this voltage exceeds 0.7 above, काय होतं, ट्रान्झिस्टर इज ऑन. इथला व्होल्टेज ऑन झाला म्हणजे VBE जंक्शन ऑन झाला म्हणजे T1 इज ऑन, गेट्स पाथ फॉर द करंट फ्लोइंग. म्हणजे इथून करंट फ्लो झाला म्हणजे काय, मोटर स्टार्ट रनिंग. किती वेळपर्यंत असणार आहे? अप टू दिस टाइम इंटरवल T ऑन पिरियड पर्यंत. हा T1 आहे. ओके, नाउ आय एम इन्क्रीजिंग दिस क्लॉक पिरियड टू दी मॅक्सिमम ड्युटी सायकल 80%. तो काय होईल मग, जास्त वेळ मोटर पण रन होईल अप टू दिस T1 पिरियड. मीन्स the speed of this operation running motor I can control by varying the PWM width, which duty cycle of the width. So this application used in various industry to wherever the assembly lines are there, or to some food products are there, the things will going on the conveyor, and to control the speed of the conveyor I need to use servant DC motors with the help of the PWM modules. Understood? कळले? Hello. Have you understood?
Ha. Yes, sir.
मग हेच एक मॉड्यूल आहे की जे टायमर आपण डिफाइन केले आहेत. त्या टायमर ऍक्ट ॲज द कॅप्चर as well as compare as well as the PWM, that is CCP model in the peak. So if talk about, it has the one capture module, capture 1 of size is 8-bit. So it has the two registers in that, sorry, one register in that. That is a CCP1 lower byte storing and CCP-RH for higher byte storing. And to control this capture 1 model operation, we have the CCP-CON registers. That is called as a capture compare 1 control registers to make the operation of that. Similar way, second का है, it has the CCP2 model, म्हणजे capture compare 2 model. म्हणजे ह्या दोन मॉडेल आहेत, एक 8 bits आणि 16 bits capture compare models. Okay, so second model also it has the two 8-bit registers, that is going to be CCP-RL lower byte and the CCP-R for the higher byte, and it can be controlled the same like CCP-T-CON registers. मग हे कॅप्चर कंपेअरचं काय थोडक्यात मी दाखवतो. स्क्रीन विजिबल आहे का तुम्हाला? मी जे दाखवले टायमरचं ऑपरेशन दिसते का? स्टॉप वॉच दिसते सर्वांना?
Yes, sir.
ओके. आता बघा सिंपल लॉजिक सांगतो मी. आपण आपल्या मोबाईलमध्ये टायमर असतोय. जेव्हा आपण रनिंग वगैरे यूज करतो बघा, रेस असतात. त्या टायमाला आपण टाइम कुठल्या टाइमला कोण आलेला आपण बघण्यासाठी काय करतो? टायमर सेट करतो. आणि आय वॉन्ट सर्टन व्हॅल्यू टू बी कॅप्चर्ड फ्रॉम दॅट अँड दॅट विल बी स्टोर्ड ॲज अ लॅप्स. आठवतं का तुम्हाला असं? बघितलंय कुठं असं? अजून तो लहान करतो याला. बघा मी टायमर स्टार्ट करतो आणि मला 5 सेकंदाला काहीतरी व्हॅल्यू कॅप्चर करायची. कसे कॅप्चर करा सांगतो मी. बघा आता 5 सेकंद होईपर्यंत सांगतो तिथं 4 दिस विल 5 सी हियर. सो ॲट 5.6 व्हॅल्यूला मी ती व्हॅल्यू कॅप्चर केली. सेम वे ॲट 10 सेकंद ऑल्सो कॅप्चर. म्हणजे ॲट व्हॉट टाइम इंटरवल टाइमिंग इंस्टेस आर गोइंग आय नीड टू कॅप्चर आय कॅन कॅप्चर विथ हेल्प ऑफ द कॅप्चर रजिस्टर मॉडेल. गेटिंग? दिसतं का तुम्हाला इथं बघा स्लॅब 1 स्लॅब 2 स्लॅब 3 हे 5 सेकंदला कॅप्चर केलंय, 10ला केलंय, 21ला केलेलं आहे. लाईक दिस. The same way these capture registers what I mentioned here, capture registers can be used to capture the what is instants are going and that value going to be stored in the these two registers CCP_R1 and CCP_R2. 16-bit value can be stored. Understood? कळलंय का? तसे आपल्याकडे दोन मॉडेल आहेत, कॅप्चर 1 मॉडेल आणि कॅप्चर 2 मॉडेल. CCP1 CCP2 दोन म्हणजे ते कम्पेअर पण दोन आहेत आणि पीडब्ल्यूएम पण दोन आहेत. थोडक्यात सीसीपी कॅप्चर कम्पेअर मॉडेल पीडब्ल्यू मॉडेल 1 कॅप्चर कम्पेअर पीडब्ल्यू मॉडेल 2 असे दोन 16 बिटचे मॉडेल आहेत. 88 बिटचे दोन रजिस्टर आहेत त्यामध्ये टू कॅप्चर द व्हॅल्यूज इन दॅट. कळले का? मला फक्त लॉजिक सांगायचं होतं काय होतं. व्हॉट व्हॅल्यू आय नीड टू कॅप्चर. सो युजिंग आय कॅन ऑपरेट द टायमर इन द कॅप्चर मोड. सो इन दॅट कॅप्चर मोड ॲट सर्टन व्हॅल्यू फॉर एक्झाम्पल म्हटलं की मी 1 मिनिटाला मला कॅप्चर करायचं आहे, तिथे फक्त म्हणलं स्टार्ट आणि स्प्लिट 1 मिनिटाची व्हॅल्यू इथं कॅप्चर होईल. सो आय कॅन कॉन्फिगर द पीक कंट्रोलर टू कॅप्चर द सर्टन टायमिंग इंटरवल्स व्हॉट इज पासिंग ऑन. ओके, and I can take the action at that moment. That is additional features of the peak controller. Same way, comparison also I can make with the value stored in that. आता हे एक तुम्हाला अप डाऊन काउंटरचं दाखवतो. एक काउंटडाऊन आहे. जसं म्हटलं की मी इथं काउंटडाऊनला मला 10 सेकंदाला सेट करतो मी आणि रन करतो, स्टार्ट करतो. तर 10 सेकंद पासून काय होतं ते 1 सेकंद येतं. जसं म्हणलं आपण की आता टायमर कसा ऑपरेट होतो, टायमर 0 टायमर 1 FF व्हॅल्यू पर्यंत जातं. वन्स दिस व्हॅल्यू इज ओव्हर फ्लॅग विल बी रेज. आवाज येतोय? म्हणजे थोडक्यात काय झाला, अलार्म सेट झाला. तो अलार्म सेट म्हणजे काय, इंटरप्ट जनरेट आहे. कळलं? आता इथे काउंट अपचा नाही ऍक्च्युअली माझ्याकडे, मी बघितलं ह्यामध्ये. हे बेसिक्स आपले सगळं ऑनलाईन आहे, आपण युज करत नाही कधी. लक्षात ठेवा. सो टायमर विल बी सिंपल टायमर ऑपरेशन आय थिंक. नाही येत नाही काय. ऍक्च्युअली आय नीड द काउंट अप काउंटर व्हॅल्यूज. दिसत नाही कुठे मला. लिव्ह इट. चला मला कन्सेप्ट सांगायचं, मला कळलं ते, दॅट इज इम्पॉर्टंट. So in the peak controller we have the two modules of capture 1 and the capture 2. Okay, so आता त्यातला आपण capture 1 बघूया and then we'll stop it here. Okay, आता what is the models are there, म्हणजे capture कोण करणार, capture compare कोण करणार, PWM कोण करणार. मग ते timer except timer 0, timer 1 and timer 1 can be used for the capturing as well as comparing purpose. So timer 1 can act as capture also, and timer 1 also act as a compare, and timer 2 used for the PWM generation. So based on this, now we are having an exam. Mostly MCQ asking like this only. So timer 1 act as dash dash and dash dash. Options: capture, compare, capture and compare, capture and PWM, compare and PWM, and the PWM. So you need to select such options correctly. Also, timer 2 supports for the pre as well as the post scalar values. What is the size? Okay, 1:1, 1:2 means based on the values 1:16. 4 times 4 bits are there. T out PS 0 to T out PS 3. So this based on these values, I can select the values. Or sometimes if in the T2 con resistors, the values will be मी ते लिहितो कारण तुम्हाला म्हणजे अंडरस्टँडिंग पर्पज लिहितो फक्त. So in the T2 con resistor, the resistor values T out PS3 H2 T out PS0, the value will be 1000. Then what should be the post color value? काय असेल post color value? For this value, it's a 1:8. आठवत आहे ना? T2 कॉन मध्ये जरा पाठीमध्ये दाखवतो मग कळेल. हो इथे बघा. If this value will be varies from 00 ला 1:1 आहे. म्हणजे असं 1 2 3 4 130 100 म्हणजे it's a value 8. So it will be 1:8 multiplier. So I'm asking, MCQ will be asking like this also. So you need to prepare like this. Understood? Hello? कळतंय का? My voice is audible?
Yes, sir.
हाँ. ठीक है. So this I haven't as explained. So I look for the capture mode operation बघूया आपण काय meaning आहे तिथं. So we have next that is called as a capture control resistors. So how it is used when I'm using timer 1 as a capture mode operation, that time I need to use the CCP1 con resistors. And in that resistor we have to control at values to be stored and at value to be used to capture the values that can be defined in the this SFR. Okay, so we have the variable SFR in the chapter number 6. Okay, so out of this 8-bit register is there. Out of that bit number 6 and 7 is not used, and remaining bits bit number 5 and 6 CCP XX and CCPY, these two bits is for only PWM generation. PWM म्हणजे आपले ड्युटी सायकल डिफाइन करायचे आहे ते आपण इन्सर्ट करतो. म्हणजे ह्या कॅप्चर कंपेअर मध्ये हे यूज करत नाही आपण. इट इज नॉट युज्ड हियर. बट I can use the next remaining 4 bits CCPXM3 to the CCPXM0. So based on this 4-bit values 0 1 2 3 that is for the capture and comparing purpose only. म्हणजे ह्या 4-bit वन काय डिसाइड करणार मी कुठली व्हॅल्यू मला कॅप्चर करायची आहे. It starts from the 4 times 0 to the maximum 4 times 1. Okay, so that values will be there and that is defined here. 6 7 use करत नाही. 5 4 for the PWM generation only, and the remaining bits that CCP1 M0 to M3, that is for the PWM capturing mode. मग हे 16 bits कसे यूज करायचे ते मेन्शन केलेलं आहे. If all the bits will be 0, that time it will be just only capture compare mode and सगळेच मोड ऑफ असणार आहेत. Neither it can act as capture, neither it can act as compare, neither it can act as a PWM. It simply act as a timer on operation. Okay, मग next value will be 0 1 00. जर आपण ते पुट केलं तर CCP1 con मध्ये त्याचे मीनिंग काय? It can operate in the capture mode and the capturing will start at every falling edge of the clock pulse. That is meaning of that. हा पण MCQ विचारतात ना. Understood I do. If this value will be 0 1 0 1, same it will be in capture mode with the rising edge. If this value will be 0 1 1 0, कॅप्चर मोड फक्त प्रत्येक 4th रायझिंग एज ला कॅप्चर करेल तो. आधी मध्ये कुठे करणार नाही. फॉर एव्हरी 4th रायझिंग एज इट स्टार्ट्स कॅप्चरिंग द क्लॉक सिग्नल. इफ दिस व्हॅल्यू बी 0 1 1, कॅप्चर मोड ओनली फॉर एव्हरी 16th रायझिंग एज ला. Okay, so this for the one starting with the 0 1 0 0 to the 0 1 1 is for the capture mode operation. Remaining bits for comparing mode. From the 8 values 1 0 0 it will be in the capture mode, and once capture will be matched with the value stored in the capture register, the flag will be set. Which flag bit? CCP1 IF bit will be set, means compare flag will be raised. If this value will be 1 0 0 1, that time again it capture mode, clear out the match occurs and the flag will be same flag will be set. 1 0 1 0 compare mode only and generate the software interrupt. Okay, and what are the remaining higher bits are there that is for the analog convergence ADC, and after 1 1 XX that is in the PWM mode of that. Okay, so this is the internal block diagram of the capture 1 registers. एक कसं वर्क होतं सिंपल सांगतो मी तुम्हाला. Now we have the 16-bit registers that value stored in the CCPRL and CCPRH. थोडक्यात काय FF4B ही व्हॅल्यू मी स्टोअर केली कशामध्ये कॅप्चर रजिस्टर मध्ये. ओके, सो इट हॅज 8-bit लोअर बाइट अँड हायर बाइट. 16-bit रजिस्टर आहे तो कॅप्चरचा. इफ आय स्टोर द व्हॅल्यू फॉर एक्झाम्पल CCP1L अँड द CCP1H ह्यामध्ये काय झालं 4B आहे आणि ह्यात किती आहे कुठली व्हॅल्यू घ्या 18. सो टोटल व्हॅल्यू बी 4B 18. So this capture value once I copying in the capture registers, मग हे व्हॅल्यू कुठे कम्पेअर करतो मी with the timer 1 H and the timer R1 L. मग ह्या व्हॅल्यू मध्ये जे व्हॅल्यू स्टोअर होते मग टायमर मी स्टार्ट केला unless it will not come from this value, it will not generate the interrupt. That is meaning it is shown in the diagram. Okay, means I am using registers, 16-bit registers to capture this value stored in the timer registers. कुठले व्हॅल्यू मला कॅप्चर करायचे आहे तर 4B18. So once that timer will come at that value be stored in this capture register after the capturing that data. And at the same time I can generate the interrupt, that is CCP1IF in the for timer 1 also. Okay, so see this simply, but आता आज मेन्शन केले आपण बघा काय की that TT CCP कॉन रजिस्टर मध्ये जर व्हॅल्यू जर आपण लिहिल्या शेवटच्या 4 बिटच्या 100 असेल किंवा 1010 असेल तर either it can use as a capture or the compare, but only for the rising and the falling edge I can use the 4 bits only that used for the capture comparing only. जसे मेन्शन केले बघा CCP1 कॉन 0 पासून 3 मध्ये आपण जरा पाठीमध्ये सांगू देता ओके from this to this can be used for the capturing purpose only. So for that value only either in the rising or the falling edge of the clock pulse I can capture the value what is going in the timer registers. And जी मेन्शन केली फॉर एक्झाम्पल 4B18 जी व्हॅल्यू स्टोअर केली मी टायमर 1 रजिस्टर मध्ये जेव्हा टायमर काउंट तो येईल त्या व्हॅल्यूला इट कॅप्चर्स आणि स्टोअर इन द कॅप्चर रजिस्टर्स. कुठल्या कॅप्चर रजिस्टर मध्ये लोअर बिट 18 CCPR1L मध्ये and CCP1H मध्ये 4B will be stored. And once capture value the flag can be raised. I think you understood this. आपण टाइम पण झालेला आहे थांबूया इथं. ओके, अंडरस्टूड? कळलं सर्वांना कॅप्चर मोड कसा आहे काय करतं?
Yes, sir.
ओके, ठीक. So let's see me attendance and I'll record this. 36 is there. One Ganesh number टाकला नाही रोल नंबर?
आहे ना सर.
रिनेम केलं नाही तुमचं नाव फक्त दिसतंय गणेश रोपनवर.
45.
Okay, just wait. I'll take the numbers and then we'll stop it here. Let's update na 20 to 21 12 to 1 1 2 3 3 is not there. 4 5 6 7 8 9 10 10 is not there. So she got 3. 11 is there, 12 is there, 13 14 15 absent. 16 17 18 19 20 21 22 23 24 24 is not there. 25 26 27 26 27 महेश कुठे गेला? 28 29 31 32 is not there. 33 34 is not there. 35 is there, 36 is not there. 37 is there, 38 is not there. 39 is there, 40 is there, 41 is not there. 42 is there, 43 44 44 is there, 45 is okay. 45 Ganesh I know. Ganesh Rupnavar.
Yes, sir.
46 आहे, 47 आहे, 50 sorry 48 नाही आहे सागर थोरात. 49 पण नाही आहे. 50 आहे, 51 आहे. ठीक आहे. If somebody is missing, let me know numbers. तुमचा नंबर सांगा मला कोण राहिला असेल तर. And please
36.
36 आहे काय? कुठे नंबर तुमचा? नाव टाकलं नाही का तुम्ही व्यवस्थित? हा, प्रणव खरात. ठीक आहे. Please, I'm requesting, please complete the task assigned. Practical write-up 10 experiments must be completed. Actually, I put the link in programming all this thing, interfacing LCD. त्याचं सिम्युलेशन पण दाखवलंय मी, व्हिडिओ बघा. Interfacing of stepper motor with the C code, interfacing of matrix also. Okay, so these experiments must be completed up to 10, and that must be uploaded with writing proper name of this thing. And I told to write assignment 1, 2, 3, and 5 and 6. 5 questions from each assignment. ते मला पाहिजे म्हणजे पाहिजे, दॅट मस्ट बी देअर. असं समजून घेऊ नका ऑनलाईन आहे मी लिहिणार नाही, चालणार नाही माझ्याकडे, त्याशिवाय मी करणार नाही, फॉरवर्ड करणार नाही पुढे टर्म ऑफ. सो आय एम गिव्हिंग टाइम अप टू द 25th. आफ्टर दॅट आय विल नॉट आस्क एनीबडी. डायरेक्टली तुमचा टर्म तुम्हाला दिसून जाईल काय असेल ते. आर यू गेटिंग द थिंग्स व्हॉट आय सेड? हॅलो.
Yes, sir.
हा, प्लीज म्हणजे थोडा फोर्स करू नका की 25 तारखेला मी टाइम दिलेला आहे, कम्प्लीट करून घ्या. थँक्यू.